Hello everyone, welcome to the sessions of programming in Python. In today's session, we are going to focus on the topic exception handling. So as the literal meaning of the word exception goes, which means uh, anything unusual, anything extreme, right? So even in Python, sometimes things may go unexpected. If your programming is correct, if your instructions are correct, then obviously your machine is going to run perfectly, it's going to output the right results. However, sometimes the code may go wrong syntactically or logically, which may throw up an error. These are called as uh, exceptional cases, right? So during the runtime, if such exception comes, if such erroneous situation occurs, we should be in position to handle. Otherwise, it could create hazards. For example, if in Python you're writing a code for a banking software or say a software for an aerospace software, then what happens if something goes wrong in the middle? That can create a huge loss of safety, security, as well as revenue losses, right? So this is, as a software developer, whatever logic and whatever code we write, we can never afford to have uh, errors coming up in the code, exceptions coming up in the code. We should be handling it. So how do we handle exceptions in Python? Well, before we learn how to handle the exceptions in Python, we should know what are the keywords or the concepts which is available to us. So first, let's try to understand what is the basic syntax of writing the code in a manner which can handle the exceptions. Let me put it down. So as you can see here on the screen, there are two keywords written here. Just like in the decision making, you have if and else. For the loops, you have while loop, for loop. Similarly, the concept of exception handling in Python has these two keywords, try and except. So this is the very basic syntax. Any code that you want to run first, yeah, that is the real code that you want to run first. For example, I might want to take an input from the user. For example, user input, okay, and this is the number which I want to take. So I'll use the int function to convert into numbers, and I'll through the input function, I'm going to ask user to provide a number. Please enter a number. Okay. So as you can see here, what's happening is through the input function, I'm asking user to provide a number, and using integer function, I'm converting into integer, right? And post that, I'm going to print. Uh, maybe I'm going to half value. Maybe I'm going to divide that uh, by 2 to reduce the value by half. And this is what I'm going to print it here. When reduced by half is something like this. So what's happening here? See, there is definitely a case if you are giving an actual number, uh, then it's going to run fine. But there could be a case when it asking you to provide a number. What if you provide an alphabet there? What if you provide, say, hash or at the rate or comma there, something undesired? Then how is that irrelevant data which you have provided is going to be converted to integer? It cannot, right? So that's an error. Python is going to throw up an error. So when it throws up an error, that's rather than preferring that your Python code should crash, what we have written here is we have put this block of code in try, so that we are telling Python, try this block of code. And if some error comes up, you're going to immediately jump from the try block and you're going to come back here. Okay. So I can write here value error. Okay. So I'm saying that in the event of except value error, and I'm going to write here a code like print the input you have provided is invalid. Okay. Okay. So what I am doing here is, instead of letting my Python code crash, I have preferred printing a message that your input that you have provided is invalid in this exception block. Okay. So I am catching this value error, right? So if I run this code, you will see that the Python is prompting me to provide a value. If I say 5, uh, it is running all fine, right? So if no error occurs, then only try block is going to be executed. Except block is going to be ignored. Just like your decision making, in decision making you have if and else, right? If the condition is true, then if block is going to be executed by the Python. Otherwise, if the condition becomes false, you execute the else block. In a similarly, you are running all the instructions that are present in the try block one by one, but somewhere in between, if any error comes up, rather than crashing, you immediately abort or jump out from this try block and you come back into the except block and you execute whatever is written here. So basically, except block is a plan B or a backup option. You don't want your Python to crash, rather execute this. Let me run this again now. This time I'm going to give here, say A, okay? A, which is going to be converted to integer and divided by 2, which is something invalid operation, right? So if I run this, you see, it immediately printed this, that the input you have provided is invalid, right? Okay, this is one. Now what I have written here is, I am catching a very specific error, okay, which is value error. If I don't write this value error, then also it is fine. You know, these are the errors which have the categorizations. Some things are for the input, invalid inputs. You have value error. If you're trying to divide, a number by 0, then you get a 0 division error. That's another category. If you're trying to opening up a file which is not present or whose access is denied, you get permission error, or so there are different kind of error. But you can always write only except. If you are not aware that what kind of error you might face, if you want to be ready for any kind of error, you can just write except, so that be it any kind of error, you can jump directly here. If you want to handle only certain type of error, then you can write here that kind of error, you get here. Okay, now say suppose I want to handle another kind of error, that is division by 0. Okay, so let me write here, let me ask for another number like user input 2. Okay, and I'm going to ask here 2. Okay, and here what I'm going to do is I'm going to do the division. Okay, and here I'm going to write the value of the result of division is, okay, if I give the valid values, like if I give here 10 and thereafter I give here 3, then you're going to see the valid answer, right? But let me give here, in the first one, let me give 10, and the next time I give 0. Okay, what happens is you immediately see the Python is getting crashed, isn't it? And you can see that the category is 0 division error. So if I want to handle this error also, then I'm going to write another except block, that in the event if you're getting this error, what I'm going to write is the second number is 0, which is invalid. You should have provided a valid value, right? So you can see here, I am trying out to execute a code. But if that piece of code is throwing some error, I am catching that error and accordingly handling that error. Okay, these errors always have categories. Now, whether it is value error or zero division error, in case I do not want, I am ready to handle any kind of error, then rather than putting any specific categorization, I can just write try and accept. This is also works, okay? But however, when I'm writing the individual categories, then I am handling them individually. So let's see what happens now. If I'm giving the first number as 10 and the second number as 0, you see, I have handled that in the second exception, isn't it? So this is how the whole exception handling concept works in Python. You have two keywords, try and accept. You have two blocks, try block and accept block. Any code that is your priority to run, and you want to run as a first priority, you put it in the try block. Anything goes wrong, you always have a plan B or as a backup action which you write in an accept. Okay. Now another thing is, sometimes you might want to know what error has occurred, right? So there is a way to catch error. Here you knew that it could be a value error. Here you knew it could be a zero division error, but you really want to know what kind of error it is, then there is a syntax to write. I can write except exception as error. Okay, so this is some temporary variable which is going to store, catch your exception data and store in it. I could have written error or I could have written data also. Okay, now let me print here data. Okay, so what's going to happen is, remember this exception that you write, it has capital E. So what's going to happen is, if something goes wrong here, obviously it is going to throw an error. You immediately abort this try block and you're going to come back here. So when you write your except block in this particular format, the exception that is being raised, the exception situation that has come up, it is going to be caught. The details are going to be captured and stored in this particular variable, which you can print thereafter. So if I run this and I say maybe 15 and I say maybe at the rate, I'll say, okay, what it says here is invalidated for integer with base 10. Okay, so here you got the data. Okay, the same thing if I run 10 and if I say 0, it says division by 0 error, right? So these are the ways to handle the exception. Remember one thing, if you're writing try, you cannot just have try. You will always have to couple it with except. Just like, unlike if and else, wherein if can exist independently, however else cannot. If you want to use else, you should always have a preceding if, right? So if and else go hand in hand. In a similar way, try and except go hand in hand. If you're writing a try block, you will have to write except block, because what if something goes wrong here? You definitely need a except block to execute, right? Apart from this except, there is another two block which you can associate your error handling with. One is else block, and then one is finally block. Okay, what's happening here is, see the as you know, these are the two things together. If your try block is successfully executed top to bottom, then obviously your except block is not executed, right? But if something goes wrong at any point of time, you execute this. When does else block gets executed? The else block gets executed if your except block did not get executed. Okay, and your finally block gets executed every time. Okay, so I can show you here that print I am in try block. Okay, and then the same thing I can write here, I am in except block, and the same thing I can write here for else, I am in else block. Finally block. Now let me try to do one thing. Let me create here a list here, something like, say, colors is equal to, I'm going to create a list of colors, red, orange, purple, violet. Okay, I'm going to print here the color. Okay, color, whatever is stored at the 0th position. All right. So let's see what happens. If I run this, you will see that I am printing red. So there was no error. So I have printed, I am in try block. And then because there were no errors reported, exception block has been skipped and you executed else block, right? Because exception was not executed, you are coming into else block. Okay. And finally blocks always get executed. Okay, so if you have certain task, okay, and you are executing or running the task here and you're ready to handle any errors, then you write the handling code here. And if no error comes here, maybe you can write here uh, task successfully completed. Okay, maybe because you're sure that since this is not executed, obviously the task must have completed, right? So that is why else is. Okay, when I say finally, whether there were errors or there were no errors, you still want to do something, then you write that in finally block. Okay, now let me introduce here some error. I'm going to write here, I'm going to access the 15th index. Now there is no 15th position here, right? 0, 1, 2, 3. There are only 3 positions because there are just 4 elements here. And I'm trying to access 15, right? So what's going to happen is, if I run this, you will see that try block got aborted because there was an error here, isn't it? And it says I am in except block. Now, since except block has been executed, the else block is going to be skipped. And like I said, finally block always gets executed, right? So this is how it works. And now let me write here another piece of code that can showcase you how each block could be useful to you, could be of your purpose. Try, except, else, and finally. See, it is not necessary that you use rest of them. Uh, your code can work with try and except also. You can enclose your code, whether the whole code or a piece of code, you can use try and except n number of times. Time and again repeatedly you can put try and accept, and you can put any number of codes here. From top to bottom, because you are just playing safe. You're trying to execute some code, and if something goes wrong, you have a backup option, right? And this, what you see here, is a classic example of, I'm trying to ask a number, trying to divide something. If there's a value error, I am handling it here. The else block is, so this else block is executed only if there are no exception raised in try block. Yep. And finally is, this block is always executed regardless of whether an exception is raised or not. Okay. So as you can see here, I'm doing my calculations in try. Something goes wrong, I am printing a valid error message. If there were no errors, then I'm printing the results. Else, I'm just providing some gratitude message that thank you for using the program. Okay. So this was about uh, exception handling. Okay. Another concept that you're going to learn now is raising an exception. Okay. So it's something like, how do you raise an exception? Okay, so you yourself are going to raise an exception. Like I said, all this while Python was automatically detecting it's an invalid input. You're trying to divide by 0, isn't it? But now what if you want to raise your own exception with your own individual error message? Then how do you do it? Let's try to understand. For example, now here I'm going to say, I'm going to create a function, maybe define, okay, let me take an input from the user input int. Okay, and I'm going to check if user input, let me make it more meaningful variable, is less than 2000. Then I'm going to say raise. So error, if you want to raise an error by yourself, if you want to raise an error by yourself, you should use the keyword raise. Okay, and I can say value error. Okay, and within the brackets I can write a message. Your age is, the age provided is less than 2000, which is invalid. Users born after 2000 are preferred. Okay, so this is my error. This is my error message. Now if I run this particular piece of code, you can see that it's asking me my age. If I say 2005, and it's going to be fine, yeah, no errors. But if I run this code and if I say 1995, it's going to give an error, right? And the message is this, isn't it? As you can see here. Now if you, as you know that this is the error which you yourself are raising with a meaningful message, what if you want to handle it? You don't want your piece of code to crash. So you can, perhaps you can put this in try block like this. Okay, and then as an except, maybe I can write print some error has occurred. Okay, so I am trying out some code. Okay, if something goes wrong, I know that I'm going to raise an error by myself. And since an error is raised, I know that I'm going to jump away from the try block and come into the except block. And in except block, I am printing a message here. Some error has occurred. So you can see that if I put here 1985 or 1975, you see a message has come, some error has occurred. And like I said, if you don't want to print your own message, but rather you want to catch what error has come up and what is the error message, then you can write or modify the except keyword here. You can write it in this format. You can write exception, E capital, remember, exception as maybe E. Okay, I can give here any variable, whether it's E or error. Let me give error here because it's more meaningful. And I can write here the message in more meaningful way. Error has occurred. Okay, the details are, now after this I'm going to print error. Okay, so if I run this and I give here 1800, okay, and it says that error has occurred, the details are the age provided is less than 2000, which is invalid. Users born after 2000 are preferred. So as you can see here, I am handling my error in this exception handling, right? Okay, so this is one, this is how you raise an error. Why would you need to raise an error? Maybe because you're developing a code and you want to check multiple conditions, okay? Numerous condition you want to check. And if certain condition is something which is undesirable to you, any input, any condition, and you want to handle it, or you don't want to proceed in a code, maybe you can prefer to raise an error, okay? So that user know, oh, something is wrong. You're trying to read a file, but file doesn't exist. Give an error there. Yeah. So this is how we use raising an error, and this is the concept of handling an error. Another concept that I would like to bring into your focus is if you're trying to raise an error by checking or validating certain condition, then there is another keyword which is present at your disposal which you can utilize, and that is the concept of asserting a condition. Okay. And you can see here that how do you assert a condition and what does it mean to assert a condition. So when you run a program, you might want to keep checking if this condition is met or that condition is met. All the while, uh, the input data that is coming is fine, but for you, it is not desired. For you, it's an invalid value. For example, I write data 1 is equal to 50, and I write data 2 is equal to 0. If I try to do the division here, data 1 divided by data 2, then obviously you know that it is going to throw up an error because data 2 is 0, right? So if I try to print the result here, it's going to throw up an error, isn't it? Like this, right? Zero division error. But why should you let Python go into the error situation? You yourself can be be sure that the data was correct already, isn't it? So you can assert beforehand that data 2 is not 0. So what I'm going to do here is I'm going to put the keyword assert here. So what assert does, it asserts a condition. Okay, it establishes the fact that it is true. If it is not true, if it is not true, then you can raise a customized error message. For example, I say error assert data 2 not equal to 0. Okay, here what I'm checking is it is not equal to 0. If it is true, it's going to well and good. If it is false, then this message that I'm writing separated by comma and put in the string quotes, I'll write the data 2 is 0. Okay, invalid input. So what kind of error this is going to raise? It is going to raise assert assertion error. Okay, because you're asserting something. You can write as many assertion as you want. Okay, for example, here I can write data 1 should be less than, should be greater than 50, and I can write here the data 1 is not greater than 50. So when you are writing any code, you're going from top to bottom, executing your code. And if you want to test your own conditions, okay, and if certain condition is not met, you can assert these conditions like this as a fact if they are true. If they are true, then nothing is going to happen. The code is going to run normally, something like this. So as you can see here, if I give here 80 and I'm going to give here 2, if I run this, you will see that it says 40, right? But the moment I make it 20, which is obviously this assertion will fail, I'm going to get a message here. The data is not greater than 50, isn't it? So I'm throwing up an error. If you want to handle the error, perhaps I could have rather put it under a try block. Please try out these assertions. If something goes wrong, let me handle it by accept exception as data print data. So what I'm going to do is I am going to catch the error message and print it idly. Okay. So look at this. Okay. If I run this, something is wrong. Okay. It's an indentation issue. Yep. So as you can see here that Python did not crash. I just handled it. I caught the error and I printed the error, right? So this is what something you can do. And if I change this to 0, you will see that this assertion will get failed and this error message shall be populated. Yeah. So as you can see here that, let me make it 90 here first. Perfect. And you can see here that the second assertion failed. See, it is not necessary to put in try and except block. It is just that it was my choice to put this block of code because I knew that an error could be raised from here. The assertion error. The assertion error are I am trying to assert the truthfulness of certain conditions. If they are true, I'm going to move on. Normally, if they are false, I'm going to raise an error, an assertion error with this particular message. Okay, so this is the style in which you raise an assertion error. Okay, and this by writing the raise keyword, I can give the class of what kind of error it is, and then I can give here the message here. So this is another way. Okay, and just like I was using raise here, I could have also used assert here. If you want to see how I could have utilized the assert here, so I am asserting this, and I could have just put here comma and this. Yeah. So instead of raising any specific error, this is also another way to do it. So let me run this piece of code. If I'm running this and I say 1950, you see it's the same thing. So well, concluding the concept, the exception handling is a concept in Python which can handle any errors or exceptions which are coming up during the normal execution of your code. And you don't want your code to crash or behave unusually, abnormally. Rather, you want to handle those exceptions. You want to handle those error situations. And that's why you have certain blocks like try, except, and the else, and finally. You can utilize them interchangeably if you want to write a safe and good code. And if you don't want to leave raising of an error onto the computer, and you have in your own mind that I want to test this condition and that conditions for the values and want to raise the error myself, then you can use assert or raise keyword. Okay, so this was all about the exception handling in Python. For more, please go through the notes which are associated with this particular session, and any queries, just reach out to me individually. Thank you.